All right, so I'm embarrassed. Not embarrassed. I mean, you wouldn't have known, but I always like to share stupid things I do because I do plenty of them. And I recorded this video already for 9.3, and then like I uploaded a couple of them parts, and then I forgot to do the others, and I deleted videos from my phone. So I accidentally deleted this before I uploaded it to YouTube, so I'm redoing this. So that is why you'll see in the next part it's handwritten. So I feel very, very silly, but hopefully you find pleasure in my pain. I know Miss Garcia will. All right, are you ready for more? So this is an optional activity, it's extra credit, but I'm gonna post a link to a video our very own North in my third period class made this awesome video for his POW, and it was actually on this topic on Eratosthenes. I really should watch his video again so I learn how to pronounce it. But he does an awesome job explaining this concept about how he was able to find the circumference of Earth using shadows. So what I'd really like you to do, if you want extra credit, is to watch this video. This problem is slightly different. They use different angles, different locations. Obviously, this is ancient Greece, and this is in the west coast of America, United States. So they're different problems, but the concept is the same. So if you can watch this video, understand it, give this one a shot. It would be a really great opportunity to boost your grade, if that's something you want to do. All right. What we are going to do, all of us, is going to take a shot at this 9.3. And so this is normally an activity we would do as a class. Again, any activity this remote learning we usually do as a class, but this one in particular, you need a partner to do. So, it's going to be sort of difficult to do that remotely, so I'm going to try my best. So we'll see how it goes. All right, so basically, the way this works is you're given a circle. I actually ended up drawing the circle. I always think anytime you're doing a problem in geometry, you should draw a diagram, so that's what I did. And it tells us that our partner has info on the shaded sector. So this sector right here that's shaded. They want us to find the area of the circle. So that means the entire circle, both shaded and non-shaded areas. So let's think about what would be some good questions to ask in order to try and find out this information, right? We want to find the area. Area equals pi r squared. All right, so let's brainstorm a couple questions, or at least three, I would say, you should do that you think would be useful in answering this question. Okay, so hopefully you put down at least three. I'm going to put down, I came up with 6. It's not to brag, but just to show you that there are a lot of possible questions you could ask. And if any of you have the ones I didn't put, I'll be happy to add them after. All right, so first one I thought, all right, if we're trying to find area, what's the radius? That would answer my question right away. Maybe they don't have the radius, maybe they know the diameter. Because if I know that, I can definitely find the radius. I just divide the diameter by 2. All right, so that's all I could really get. I guess they want us to find the area. I could ask, like, what's the circumference? That's another part of the whole circle. So all these three refer to questions of the circle as the whole. Now I'm going to focus on questions that refer just to the sector. So the first thing I think about when I think about the sector is, what is the measure of the central angle? What else could we ask? Well, I could ask, what's the area of the sector? And then lastly, what's the length of the arc of the sector's arc? So 1, 2, 3, 4, 5, 6. Yeah, 6 questions. Okay. So let's see, if we were to ask that, would it be answered? So the first question we asked was the radius, and unfortunately, they do not have that. Now we ask, what's the diameter? they don't have that either, which sort of makes sense because that would be too easy. If we knew either of these two right away, it would just give us the answer. We could just plug it into our formula. All right, what's the circumference? Unfortunately, that is not available either. All right, now we could ask, what is the measure of the central angle? And that they are able to tell us, and that's 240. And if they ask you, why do you need the measure of the central angle, you have to come up with a reason. So why would knowing the central angle be beneficial to finding the area of this whole circle? Well, we're really trying to find the radius, right? Because if we find the radius, we're done. So I don't know the area, I don't know the circumference. So the only other formulas I can think of that include radius are going to be my area of the sector and length of the arc associated with the sector. So both of those formulas use the central angle. All right, area is going to be theta over 360 times pi r squared, and length is going to be theta over 360 times 2 times pi times r. So both of these use r, but they also use theta, so I'm definitely going to want theta. All right, now look, I have two different formulas, so I can really choose whatever I want. That's got an exponent, so maybe I don't want to deal with an exponent. I'd rather deal with, just the lower equation, which doesn't have the exponent at all. So I'm going to ask, what's the length? What's the length of the arc defined by the sector? All right, and that they can tell me too is 12 pi. So now I'm going to plug in all this info I know. Okay, so the first thing I'm going to do, I want to get r alone, right? Well, one thing I can do, and this only works when it's a positive or negative number. If it's 0 on both sides, I can't divide both sides by 0. But here I see I've got pi. I've got pi on both sides. Sorry, I've been talking all day. Re-recording videos I already made. So I got pi on both sides, so I can cancel those out. Really, I'm dividing this right side by pi and this left side by pi, and I cancel out the pi's. All right, moving on, we're left with 12. Oop, oh, no one, wait, oh God, I hope no one saw what was down there. Whatever, it's okay. It's all gonna be okay. All right, 12 is equal to 240 over 360 times 2 times r. All right, now I want to get rid of this big fraction. My favorite way of getting rid of fractions is multiplying both sides by the reciprocal. The reciprocal, you know, remember from our coordinate geometry unit, means like the flipped version of the fraction. So if I multiply on the right side by 360 over 240, these are just going to cancel out. If I multiply this left side, well, that I'm using my calculator for, because I don't want to do that in my head. So all my fractions are always in parentheses, 360 divided by 240, and then I'm going to multiply that by 12. And we're going to get 18 is equal to 2r. Divided by 2, 18 equals r. So if my radius is 18, again, that's not what they're asking us to do, right? What they're asking us to do is find the area. So now I can just plug that value for r into this equation. We're going to get pi times 81, or really just 81 pi. And since we're talking about area, and they do give us the units here, they give us feet, over feet squared. Right, anytime they tell you units, you have to make sure your final answer also has units. All right, great. So now let's look at down here. Same situation, a slightly different sector. Now they want us to find the circumference of the circle. So knowing what we know now, right, think of the first question you're going to ask. Okay, so I'm just going to open it up differently this time. The one thing we didn't learn last time was the area of the sector. So that's what I'm going to ask first. What's the area of this sector? And so we get that the area, they'll tell you, well, why do you want to know the area, right? Just like last time, well, I want to know the area because if I know the area, then I can I can solve for r. I need the area and the central angle for that equation. All right, if we look at our equation, area equals theta over 360 times pi r squared. I look at this equation, I've got 1, 2, 3 variables, right? If I have an equation with 3 variables, and I want to solve for one of the variables, right? I want to solve for r. That means I have to input an actual number in for a and in for theta. You can only solve for one variable at a time, so the other two cannot be variables. So that's why I need that. So give me the area and give me the central angle, please, right? Don't be rude. And I'm gonna find out from the problem that I've got 40 pi is my area, and it's in feet squared. So again, we're in feet, and 144 is my central angle. Another thing you should know is that we could have used, sorry, the sounds not very dramatic. We could have just used the length as an arc, right? Just like we did in this problem up here. Either way, we're going to solve for radius, so it doesn't matter if I use area or length of the sector. So again, we got pi radius squared. So same thing, cancel out pi's. All right, that's a nice thing about keeping things in terms of pi. If you see pi on both sides, you can cancel it out. Now I'm going to do something that I think maybe some other students are doing. They see that fraction, they don't like it, so they're just going to plug in right away 144 divided by 360. And we get a reasonable fraction of 0.4, right? That's something that I'm comfortable dealing with. All right, now I'm going to divide both sides by 0.4. The operation combining 0.4 and r, right, is multiplication. So we're going to divide both sides by 0.4. 40 divided by 0.4 is 100. 100 is equal to r squared. All right, what would I do next now to get r alone? We would take the square root. Now, what is the square root of 100, right? Most people would just say 10. But in actuality, there are two answers, right? We could have positive or negative 10. That could be equal to my radius. But of course, we're talking about radius, a real life length. Anytime I'm talking about real life dimensions, right, we're really talking about the positive values. All right, so I'm trying to find circumference. So my formula for circumference is c equals 2 times pi times r. C equals 2 times pi times 10. C equals 20 pi. And we're in feet, so that's the circumference. All right, that's all for 9.3.